So one entity in our data model sits in a couple different places. So we have a piece of content that sits in a document store. So we have JSON for it. We have a node reference in the graph, and it essentially has a search index backing it as well. So for metadata search, you need that, and keyword search, that kind of thing. And then you'd also have one or more vector embeddings. So like a podcast might have 100 vector embeddings because of the chunking. So there's like this footprint that lives in actually like three different systems, and that we've kind of created like a hybrid approach. So you kind of have like a virtual entity that literally has physical representation in three different databases. And I think over time, you'd love to not have to manage those three different systems for that. I think that'll evolve.
Hey buddy, welcome back to another episode of How AI is Built. Today we have a very special guest. Kirk Marple is the CEO and founder of Graphlet, where he's building the ETL and the knowledge retrieval for LLMs. If you want to learn how knowledge graphs actually work below the hood, or how to build, query, and traverse them, this is the episode for you.
A little bit of history. So I had this company for 10 years in the broadcast video space, and then was CTO of a couple of different places for, I guess, about 3 or 4 years after I sold it. And then started working on this concept of indexing all data in time and space. And so unstructured data. And I tried to build it, like we were building it at a couple of companies I was at. And then I really had the urgency that I really wanted to continue this myself. And so I ended up raising money about 3 years ago. And we kind of went top down. So we did a data cataloging tool for unstructured data. And I had already started working on the platform before that. And then what we realized about 18 months in was people like were still using SharePoint. I mean, they were still trying to figure out the tools they had. And what I realized when LLMs came out is that you could build so many little niche vertical apps on top of a platform like this. And so I pivoted to Graphlet about 18 months ago now as just an API. And so now it's like, okay, anybody could build a product like this. And that was really how we transitioned to Graphlet.
Yeah. And how is it used in production like now? Do you have any like interesting but also favorite use cases?
The low-hanging fruit these days is still that co-pilot kind of concept of I have a set of domain-specific data that's either user-gen content or it's like healthcare content or fintech content, and they want to basically integrate that with LLMs. And so chat about it obviously is the easy approach or the first place people start, but now it's more like getting into like repurposing that content. And so one of them, somebody's building basically a tool for podcasters where they can have all of your episodes and help you prepare show notes, prepare ideas for the next podcast, kind of look back at what's already been discussed. And that's a fun one because it's kind of where I started with this. But I think, another is just, having in production copilots that users are uploading data every day and they're using it live. We have several of those that they moved over from open source tools to us within a couple of days. I think for me is the best thing. We wanted to really make it easy and not have to have people build all that infrastructure themselves. So those are the kind of ones that I enjoy that we can basically get people up and running on the platform very quickly.
And most use cases I actually see are still mostly RAG based, only with vector databases, some with a full text search added. What do knowledge graphs add on top of that in potential?
That's really where I see it gets interesting is, we had already been doing the keyword and the metadata filtering side of it when we started the data cataloging. And so we were kind of auto tagging content, letting you filter by that. And then we had an idea, and this was 3 years ago, had an idea of integrating vector search. And until Pinecone came out and embedding models were available, like it was still a little bit of a research project. And then that kind of flipped where that became really easy to integrate. And so the good thing for us is we kind of went the direction of keyword metadata into vector. And I see a lot of other companies are kind of starting with vector because they're just dealing with text. And now they're trying to integrate metadata and integrate all the other pieces. And then the knowledge graph is really a layer on top of that, where we can use it as a filtering mechanism. So if you extract entities like you as a person, Graphlet as a company, Seattle as a place, we can automatically filter the domain of data that you're chatting over. And this is something we're actually roll out this quarter. And I have a talk coming up in 2 weeks at Microsoft Build about kind of auto detecting entities in the prompts and then using that as a filtering mechanism. So you can sort of limit the amount of data that you're chatting over. And so that's where, knowledge graphs as a filtering is part, but then I think also the kind of spidering and pulling extra content in is the other place this comes into play.
I'm really curious what technology or what combination of technologies you're actually using for the entity detection.
So right now, we've been using Azure Cognitive Services. Well, I guess now they're called AI Text Analytics. We'd used that in the past, but we also support anything that can give us JSON back. So any of the models that are reliable about giving JSON, GPT-4 Turbo, is really good at this. But we've actually seen even Claude Haiku working pretty nicely for the prompt entity extraction, where you're typing in a prompt and you just want to grab those individual entities. Haiku works really nicely for that as well. So I think, since that's sort of a pre-processing step, we want to keep that really cheap and fast. So GPT-4 Turbo would be like way overkill, but I was happy to see that Haiku and Cohere's Command R, which we support too, actually works. And then we're looking at the Grok models as well.
How do you see something like Spacey, so more the old school NLP fitting into this?
There's still that part of it. Basically, the classic NER, we can start with that, but then we can even do enrichment. So there's a balance between, like, the LLMs are really good at getting JSON LD and like pulling the pieces together, like an address, where you're pulling together the location and maybe it's across a couple different parts of lines of text, and it can coalesce that into an address structure. The classic NER, it'll find like Seattle as a place, and that it's not as good as that. But what we found is for the more complex metadata, the LLMs are way better. And so we kind of use them in conjunction. You can even use one to guide the other. I've seen that talked about online, and we've even dabbled with it where you do a first pass, find the entities, the named entities, and then give that back to the LLM and say, hey, go grab everything you could find about these entities. And so you can stack those things together.
Yeah, that's really interesting. Why do you think knowledge graphs are not really common practice yet?
It's interesting. I think there was the transition from relational to like kind of NoSQL database models and people kind of understanding that. Graphs to me are kind of like index per se. So you're really like the entities or the records in the database are still pretty much the same, but you're providing a new type of index on top of that. And I think a lot of people just haven't been familiar. There's Neo4j and there's a lot of great graph databases out there, but they've been kind of bespoke, like they've been special purpose. But we did sort of a hybrid where we have a NoSQL like JSON document store, we have keyword search and all that kind of stuff, but then we have the graph as kind of the index that points back into the document store. And so I've been looking for a database that kind of was a hybrid, like a searchable database that could store a lot of JSON. I couldn't find one. And so I built kind of my own hybrid of that over the years. And that I think you need to have, a lot of graph databases, you can't store a lot of data with the node. And we use Azure Cosmos DB. You can store 2 megabytes of JSON with a node in the document store, but not in the graph store. And so that's why we kind of had to have a hybrid to put those together.
Yeah, and there are a few interesting projects like embedded graph databases, for example, KuzuDB, which are coming out. I think part of the complexity in knowledge graphs is it's so open what you can do with them that it's hard to wrap your mind around what you actually want to do. Because most people, when it's too free, you can't really imagine a use case.
That's spot on, because what we've seen is you could take graphs a lot of different ways. There's the kind of graph algorithm side where you have like a ton of data, billions of nodes, and you're running complex algorithms on it to infer insights. And we're kind of using it a different direction where we're not dealing with like billions of nodes from the unstructured data. It's really hundreds of thousands of nodes a lot of times where you're pulling out these named entities. And the graph is really there to support RAG and to support retrieval. But you're right, like you can use knowledge graphs in so many different ways. And for us, we're taking more of an opinionated approach, which we've picked a direction because we're leaning into the like JSON LD schema.org taxonomy and basically saying, hey, we're going to build a native JSON LD knowledge graph from your data and then use that for search. But that we're leaving a lot of stuff on the table where it's not a totally open-ended knowledge graph. But I think you have to find constraints to make it workable for something like RAG.
And for something like RAG, what are the common entities, so the nodes and the relationships between them you see repeated across projects?
So, what we support today, I think, is about 8 or 9 of them. People, organization, place. We do product, software, and repo, and then like events as well. I probably forgot one, but it's basically like 8 or 9 standard entities that we extract and map to, and then labels is kind of the generic one. And so we can map, basically do an NER and the extraction to any of those. And then those are like native in our API, like our data model. So you can basically just assign a workflow and say, okay, use this LLM to extract entities, push all your data to us, and then go in and filter on it and say, okay, give me all the contents back where Microsoft and Seattle were mentioned. And then that's essentially like an auto tagging kind of filter. But what we can give you back is the subgraph and say, okay, well, what's the resulting relationship between all those pieces of content and those entities? And originally what we had done was what we call observations. So it's content to entity relationships where I observed Microsoft on this page. So we kind of came up with those semantics. And then what we're adding now is entity to entity relationships. And so because classic NER couldn't get you that, like they couldn't be like, okay, he works at Microsoft, but the LLMs can. And so that's what we're adding in now is basically the edge. It was actually really easy to add because we already have the edge relationships in there, but now we just have a custom label. And so we can say, hey, it's inferred that he works for X works for Y. And then that gives us the ability just to, expose that in the data model and be searchable and give it to RAG.
What are the types of relationship you really would love to add?
Those are so domain specific. That's what's interesting. Like I was actually testing this weekend with podcasts and with some documents, and in schema.org, there's already a lot of relationships, and it's like they're an alumni of, or they're affiliated with, or related to. So we're starting with those, and that covers a lot of bases. So we're using the learnings or just following the patterns of the relationships that are already standardized. We're not getting into custom relationships yet, where it's like, okay, this is drug research and this drug is related to this drug or things like that. Like we haven't gotten there yet. But I think we're trying to get more the 80-20 rule of like typical business data, typical academic data, like stuff. And that's where we're trying to be a bit opinionated and something that's very easy to use, but still powerful.
Yeah, and I think this is something that's really needed for graphs because the constraints, without them, you actually don't know what to implement. And also within these constraints, you can already do so much.
Yeah, and there's risk there for sure. But I think what we get into is that out of the box we're usable. Like they don't have to really think about their schema. We can just point and say, look, here's everything we have. It should be pretty straightforward to use out of the box. And hopefully that gives people a lot of power out of the box. And I'm sure eventually we'll get into more custom stuff, but we wanted to have a good set of functionality that we just ship with out of the box.
What are you using to traverse the graph? So what's the query language?
So we're using Gremlin today. And so since we use Cosmos DB, there's pluses and minuses to it. Gremlin's kind of a funky, like it's a text-based language that you have to create for that. I know there's GQL just got standardized on. I would imagine in a few years as the new graph databases start to standardize in GQL, we'll move over to that. The Gremlin queries aren't super complicated. It's add node, add edge, do a query. Like we're not doing crazy algorithmic stuff right now. So I don't think it would be that hard to port. But yeah, Gremlin, we've been using it for several years.
And how are you converting the actual user query to a Gremlin query to traverse the graph?
So right now, there's a pre-processing pass. We already exported prompt rewriting. So we can take your incoming prompt during RAG, optimize it for search, keyword search, or rewrite it. And then what we've done is add entity extraction to it. So we do a pass, so we pull out the entities, and that essentially auto sets your filter. So we can take those entities, see if they already exist in the graph. If they do, we can get their IDs, and then you're essentially just doing a search on the graph where you're saying, okay, filter by observations of these IDs. And since we use a search index, we're caching essentially those edges, and we can just do it via search, which is fast. The Gremlin query can be a bit slow. It's probably 10x slower than like a NoSQL kind of query. And we only use it as we walk the edges in a GraphQL resolver. So that's the place where the GraphQL queries, when you're kind of dynamically walking to the edges. And it's a reason why we use GraphQL, because the resolvers map to graph queries really well. So you can essentially infinitely navigate our data model just by following the resolvers.
Yeah, and I'm really curious because in a RAG you have like the vector similarity as the key metric and you're ranking based on the vector similarity. Then there might be some re-ranking. How are you doing that like with the added component of a knowledge graph?
That's a great question. It's actually something I've been still working with recently is there has to be a bit of heuristics. You don't get the same kind of ranking out of it that you could say it's kind of distance or clustering. And I know that there's other graph RAG solutions that have kind of tried to do things via clustering of the nodes. I mean, for us, we're kind of looking at it where you have your vector ranked corpus of data that you're giving as part of RAG. And then it's really the graph is kind of supporting material. And what we're looking at, and this is what I played around with a couple of different options. One is just do a keyword search over it to get a ranking out of that and use that to integrate with your vector ranking. Because if you just did a vector search over the same data, you're probably going to get the same hits that you did on a vector side. But I kind of see it as like it's sort of a split where you do a vector query and then you do a graph query and then you merge those back together as a hybrid. But it's not a solved problem. I would say it's a perfect question because it's something we're trying to solve of what is the right way to do that.
Yeah, and that's also probably something you have to give the user some flexibility to actually set the weights between the different scores you calculate.
Yeah, and we do some of that. We have some weighting mechanisms in our system for configuring things. And I think you're totally right where you could say, okay, like here, pull in this amount of content from the graph. Because a lot of it is, I mean, it could be totally random content. I mean, just because it mentions Microsoft, it could be totally unrelated. And that's why we're trying to figure out the right ways to, and the right knobs to give to make it more related.
Yeah, and I think what many people ignore is actually trying to minimize the garbage that's fed into an LLM. It's a little bit something that's not that often practiced. I think there are a few interesting projects which are trying like semantic chunking to keep the chunks clean and basically remove anything else from the vector database. Is there something in that direction as well in knowledge graphs what you can implement?
Yeah, I mean, on the semantic chunking, so we just moved over to semantic chunking model recently, where originally, I mean, we'd been doing page level chunking, like as you get out from PDFs, but now if it's a type of data that we can get semantic chunks out of, we store that as a sidecar. And so it would be like chapter level or that kind of level. So, and then if it exists, we use that for our embedding chunks. But I think, I mean, with the graphs, I think it'll be interesting. I mean, I think one of the things is where was the observation taken? So you have to have a link back to say, okay, I observed Microsoft on page 3 and pull that data and then grab all of page 3 because we're not tracking chunks for observables. For entities, we're tracking pages or sections for that. And so that becomes a little complicated where it's small to big kind of retrieval model where you're already expanding that context because of where you found the entity. So I think, I mean, yeah, there's definitely a bunch of different things that we're looking at for how to get the right semantic linking to the semantic chunks through the knowledge graph. And I'm sure there's going to be a ton more work that we'll have to figure out on that.
Yeah. What do you think are the most common pitfalls when you build and maintain a knowledge graph in production?
I think, I mean, entity resolution, deduping, I think is probably the number one thing. I mean, there's companies out there that literally just solve that problem. And I think for getting clean data and understanding, like, are these really the same person? Or are they two different people? I mean, that's a big problem unto itself. I think just keeping it fresh too. I came across a paper this morning about temporal knowledge graphs and tracking things over time, which we already do a bit natively, but we're not keeping like a historical mechanism of like, hey, we've enriched Microsoft with their revenue. I mean, right now that's a replacement. It's not a versioning mechanism. And so I think that's something we could extend to that. How do you show the changes over time and look at windowed queries on a knowledge graph? I think that's difficult as well. But a lot of that is, I mean, what's the use case? I mean, not every use case would need something like that.
Yeah. And I think that's something that goes a little bit in the direction of Bill Inman with the textual warehouse, where you try actually to combine different pieces of information to stack confidence that this is actually the right thing that is being referred to.
Yeah, and I mean, one of the things we do is what we call entity enrichment. So as we extract an entity, you can call another API to feed metadata into it. So classic would be like Wikipedia enrichment. So you can turn on that. And so as we pull information and identify entities, you can then layer in more metadata, but then the more metadata actually is helpful for entity resolution. So if you're pulling from your CRM and you say, oh, here's a company name, Now I can go over here and go, oh, okay, I'm cross-referencing it to Salesforce, and actually I have two companies named that. So maybe then you can try and figure out, do you split or do you merge those entities and use it as supporting materials?
How would you actually evaluate the quality of a knowledge graph?
I mean, it's so domain specific. Like, I don't have a good answer for it because it really comes down to, are you getting the fidelity of the data that you want? I mean, are all the entities that you want in there? Are all the relationships you want in there? I think, is it able to answer the queries that you give it is an important one. But there's the knowledge graph and there's graph rag, which are kind of two different things. But I think the knowledge graph itself, I think a lot would just be coverage. I mean, you have a set of domain knowledge you're trying to cover with this entity modeling, and are you able to cover and show those relationships?
And can you a little bit elaborate, like how do you combine, like on the one hand, the embeddings from the vector storage, the documents, and the knowledge graph? Like how is all of this linked together?
So one entity in our data model sits in a couple different places. So we have a piece of content that sits in a document store. So we have JSON for it. We have a node reference in the graph, and it essentially has a search index backing it as well. So for metadata search, you need that, and keyword search, that kind of thing. And then you'd also have one or more vector embeddings. So like a podcast might have 100 vector embeddings because of the chunking. So there's like this footprint that lives in actually like three different systems, and that we've kind of created like a hybrid approach. So you kind of have like a virtual entity that literally has physical representation in three different databases. And I think over time, you'd love to not have to manage those three different systems for that. I think that'll evolve. We're always looking at other vendors and things like that to do that. But for now, you kind of have to have three different ways to look at the same entity as a graph, as text, or as JSON.
And this is basically the 3-tier storage system you've been talking about.
Yeah. And I guess really the other one is object storage. So, I mean, if there's physical file on disk, like your MP3 file or your PDF, essentially have to cache that somewhere for the metadata indexing to read from it or the parsing to read from it, that kind of stuff. But you can have storage policies to cache it for a short term or put it into cold storage or cloud storage. But there's essentially these kind of layers of the abstract representation of the entity and then the physical, the original source media where it came from.
How do you think multivectors will impact knowledge graphs as well?
So we use multivector today for text and images, but I really am interested. This is something I've looked at for years of like, there isn't just an out of the box graph embedding API or model that there's no cohere for graph embedding or 8002 for graph embedding. And I would have to expect that's going to happen pretty soon. I mean, maybe OpenAI just announced it. I don't know. But I think that will be really the next step of if we could keep a subgraph, an embedding of a subgraph of each entity, and then use that for similarity. And you could sort of fake it today by essentially caching the edges that an entity is connected to. And the JSON LD with the references to the edges in that can sort of get you there today, but you're not really being semantically aware of the edges. It's just text at that point. So it's just finding similar bytes. So I wouldn't imagine that would be very reliable.
Yeah, and you basically try to create like a representation that is lower dimensional than the original graph to speed up the traversal. So kind of in the direction of the HNSW index.
Yep.
But more in the direction of the actual knowledge. Nice. You have an approach which you call metadata first. What are the most interesting pieces of metadata you guys are extracting?
So we had gotten our start dealing with built world companies and unstructured data from drone imagery and videos and CAD drawings and things like that. I mean, now a lot of our customers are really more document and audio focused, but there are other unstructured data formats that have a ton of really interesting metadata. And I think that's when we had done a lot of data cataloging for drone flights. I mean, what camera was it using? What lens was it using? Like, was it using thermal imagery and all this kind of stuff? And so it's a lot more complex than document author, like what software a document was built on. And so I think that helped us because we kind of cut our teeth when there was a ton of metadata that we had to filter on and index. And so now audio and documents and stuff are kind of a subset, an easy subset of that. But we were doing things where, yeah, you could be like, okay, show me this geospatial region between this month and this month where there were flights that used a DJI drone with thermal imagery. And we'd be like, boop, okay, here's your search. And that retrieval engine that we built is really the heart of what we have. And it's actually a side story. I had been at General Motors working on data pipelines for the Cruise, the testing of the Cruise vehicles right after they were purchased. And that was where I kind of came up with this concept of like index everything in time and space. Like you're getting all this data, make sure that you're capturing the metadata that you don't necessarily know if you're going to need it later. But as long as you're indexing things properly in those two dimensions and storing essentially a JSON blob of all the metadata you can find, you're going to be able to use it downstream. And you're going to be able to build a graph, you build a search index, build whatever you need. And so I kind of took those learnings of when we started this company to be like, look, we'll just pull out all the metadata we can, make sure that it's canonicalized well, filterable, and then we know it's there to be able to use it. And with RAG, it actually is great. It's like, oh, hey, now we can add a little more metadata into the context and give it a little more color on what was happening.
Yeah, and what I've been actually really surprised by is by the amount of integrations you already have. What is your decision process in actually deciding on different integrations and different tools?
Yeah, I mean, it's one of those things where once you come up with a pattern, we're able to build very quickly. And so we have a couple different patterns of one we call site feeds. So it's basically any cloud storage. And so we have a model where you can just build another service that can read, like enumerate, list, and get files from a service. And so for us, I mean, say we added OneDrive versus SharePoint. Honestly, it probably took like a day at most because we're just implementing to some API, fitting the data into a pattern that's already there, and it just works. I mean, from a decision-making process, part of it's just kind of, it's known. You need SharePoint, you need Google Drive, you need OneDrive. But there's some like confluence. Like we did Jira, and because we did this kind of sweep of issue feeds, that we did Jira, Linear, and GitHub issues, because for product management, that's useful. But then there's like things like Notion was customer driven. Somebody said, hey, this would be great if we had Notion support. I mean, it's as simple as that. And so then usually it takes a day and just go, okay, now we have Notion support. And so early on, you're kind of just trying to get as many in as you can. But at this point, we're just waiting for feedback. Like we heard HubSpot issues, HubSpot tickets from someone. And honestly, it wouldn't take that long. It's the figuring out the authentication to the services is probably 80% of the battle. And once you can figure out, okay, is this OAuth? This is an API key. How is somebody going to give us this? The APIs are so similar. And I've done so many of these integrations over the years. It comes together pretty quickly.
So your bias is rather building the integration yourself over using tools like even open source like DRT or something like an Airbyte or Fivetran.
Yeah, I mean, we have overlap. And I think I've essentially built a connector infrastructure that would be like a Fivetran or something that Airflow would have or something like that. And I've just done so many of these over the years. So it's just easy enough just to like, we just have those built in. I mean, we could add a custom connector SDK if we needed where somebody just kind of feeds us the data and we could have a plugin. But for now, it's usually so quick for us to add them because we have that infrastructure. We just end up doing them ourselves.
How do you actually decide between building something yourself and deploying it yourself versus using a managed service?
It depends is always the right answer, where there are some things that I want to have a managed service where it's like we don't want to be managing our own database, and I don't want to be managing our own cloud infrastructure for compute. I mean, I've been at enough companies where like they just get so bogged down trying to manage their Kubernetes infrastructure or, I mean, all the intricacies of that and have to end up having a big DevOps team and all this. And I'm like, Microsoft or any of the cloud providers do a nice job at that. I'd rather just use off the shelf in those areas and in database as well. So we use managed services from Azure for database, for compute infrastructure, for things like that. But from a code level perspective, I mean, we are using some open source projects for like our PDF reader and some metadata reader. We also contribute back to those. I mean, to help add features, fix bugs. But a lot of times I mean, how good is what's out there? How supported is it? That's usually a really big question. Like, is this something that hasn't been touched in a year? And we hope to open source back some things that we do eventually, but we use a different stack than a lot of people. We're a C# .NET Core, like we're now on .NET 8 now for our backend, which isn't like the popular kids platform. It's super stable, very performant. And so I think from an open source standpoint, we're not leveraging the kind of NPM or PyPy ecosystem.
And if you would look at your stack, especially the open source tools, what are some that you would really highlight because they bring so much value to you, but also because they are a little bit underappreciated from the community?
Yeah, there's one I'll call out. It's called Metadata Extractor. I think there's a .NET and a Java version, but it's a guy that, I don't know if he's still at Microsoft, but he had been at Microsoft for a while and just done a great job. Like he had ported over some of the earlier packages in the space and it kind of like built on some of that. And it's just super solid for indexing metadata. I think there are open source projects in the JavaScript space that do a lot of this similar kind of thing, but there's so many different formats, so many different types of metadata, and then bugs in the metadata that's like doesn't fit the spec that you have to handle. And it's just a really nice package that it's like one call, grab all the metadata that you need for just a wide variety of files. So I really like that. We've actually helped like get a couple new features built in there and supported them on that.
And you already mentioned a little bit the infrastructure side. It seems like you have a little bit of a bias to serverless, or did I read that wrong?
I mean, we're currently using serverless. So one of the reasons is because we're a platform as a service, the burstability of it is really important. And so I think what we're actually seeing is in our kind of SaaS offering, we're serverless today. So, I mean, say it would get quiet on the weekend, we could only spin down just a handful of instances, but people start dumping data in on Monday morning, we could spin up to 100 instances without any problem. And we don't have to think about it. And that's just Azure managing that. What we are starting to get more interest in is private cloud deployments now, where we could essentially run in someone else's Azure subscription and then they could have their own private. But we've thought about it. Like, I mean, I can see downstream running a Kubernetes cluster, but you get that always on cost. And since we're very bursty in the system, data ingestion is classically bursty. It's not consistent usage. And for us, it was a cost issue. And I moved over to it years ago when I was doing this as a side project, where originally I was dealing with Service Fabric, which is a very kind of Kubernetes-like cluster environment on Azure, but I didn't want to have to pay $100 a month, like when I was doing this myself, to keep that cluster there, because you have to pay for a minimum of 3 instances. And so I moved everything to serverless as a project and realized how easy it was. But also our design pattern is event-based. It's an event-driven system, which fits perfectly with the serverless model. And so we're able to throw a whole bunch of stuff onto Event Hub, which is very similar to Kafka, and let it partition out and just burst out that capacity. And so for us, I think event driven and serverless go really well together. And that's been the big reason why we stayed with it.
Yeah. I think in data and AI, it's so much like earned knowledge that you figure out some stuff just through trying a lot of different things and seeing it across different projects. What are the little tricks and hacks for RAG and knowledge graphs you have picked up in all your projects that you now almost use by default?
Yeah, I mean, the one that comes to mind is the XML, using XML in the prompts, which Anthropic had kind of done early on. They'd suggested to do that for segmentation. And actually now I just use it for all the models. And what I found was I backported it, or I guess once I started using it, I went back and checked all the other models and they work great with it. So we actually use an XML. At the end of the day, it almost looks like an HTML page where you have kind of a head, a body, and a footer in a way, where we can have sections that we define in the prompt. And that's how we hand all of our prompts to the models. And so, yeah, the funny thing is we're XML in, JSON out, which is kind of an odd thing, but I think it's a lot of people have probably moved to that model.
Can you give me an example? Like, how do you label the different XML fields and what are like the common ones you always include?
Yeah, so we have a context field that's kind of like what we say is like, here's the context for what you're getting. What it's going to tell the LM, what are you going to receive? That's where we start. And then we say, we're going to give it instructions and sources. And then at the bottom, what we found actually works really nicely. Originally, I wasn't doing this, but wrapping the user prompt in XML and saying, okay, here's the user prompt, and now answer this back in JSON or whatever. And even just segmenting that user prompt off had fixed a couple issues with, I think it was like Haiku was having a little trouble with some stuff. And so it's interesting, just being very explicit about here's what you're going to get, here's your instructions, here's your sources, here's your user prompt, lets it focus a little bit more. And honestly, that's all gut feel, but I mean, we've seen better responses in practice with using that.
What would you say is missing from the generative AI space?
I would say graph embeddings, like we talked about, is one of the things. I think that would be, I feel like I was on a podcast 2 years ago saying the same thing. I mean, it's just like, it's an area that hasn't evolved that quickly. I think the thing that we're seeing now is with costs, like with Grok. I mean, you don't even need streaming anymore. I have a feeling streaming may end up going away just because it adds complexity to the RAG interaction model if these models get fast enough. And so I think that'll help simplify things. I mean, I was playing with Grok Llama 3 yesterday, and I kind of looked to the side and looked back, and it was there, and it was the answer. I was like, I almost forgot if I had already submitted it or if it was the answer before. It was so fast. And I think that's going to be a game changer for once cost and performance become a no-brainer, then I think we're going to start seeing LLMs be more of a compute tool of, hey, I've been meaning to prototype entity resolution with LLMs and say, here's two JSONs, merge them or split them and give it back to me. I could write code to do that too, but that'd be, if I could just do that in an LLM call and it would be like micro pennies, I think that would be a game changer for kind of how applications are built in the future as well.
Yeah, I think it's nearly too fast, especially Grok. Like, you nearly don't have time to think anymore because the answer is already there and you have to read it and basically go on.
It is interesting. The streaming is interesting because it's like, it does give you a false sense of like, okay, I'm going to read this as it goes. So you might even see applications fake stream them back, even just kind of, it becomes more of a UX paradigm than a functional paradigm.
Yeah. So what's next for you in Graphlet? What can you tease already?
So we're going to be at Microsoft Build in 2 weeks talking about GraphRag, and we'll have some demos out. That's really the big focus. We have a new developer portal coming out shortly that has a much nicer user experience, more functionality. And then we're really focused on just kind of delivering GraphRag as a service. Really, it's a feature within our RAG functionality, but we had been focused more on the top of the funnel of getting the data into the graph. And now we're going to be delivering that as a retrieval option within RAG.
Nice. And if people are now inspired and want to jump into Graphlet, where would you point them?
Yeah, so we have our on graphlet.com. We also have some sample applications. You can just click a button, get right into a Streamlit app. It just requires a free sign up and get the API keys. But yeah, it's free to get started with. And you could look at Python code for our Streamlit apps or the documentation and get started.
And if people want to follow along with you?
LinkedIn, or I'm on Twitter, Kirk Marple, and the company's Graphlet on Twitter as well.